Hello and welcome back to Mr. Powers Teaches Algebra. Let's do this. So today we're going to talk about multiplying binomials, but these binomials are going to involve roots. Okay? And so just a little review here when we're talking about this. Let's do an example. Let's try out u plus 2 times u minus 5. Okay? So now the traditional way to do it is, u, the first term, times both of the other terms in the binomial, and the second term in the first binomial times the other binomial. Is pretty much distribution twice, and really each term times every other term. So let's do that. If we do that, we get u times u is u squared. And then u times negative 5 is negative 5u. 2 times u is 2u. And 2 times negative 5 is negative 10. And then what we would do is we would combine like terms. Negative 5u plus 2u is going to be u squared minus 3u minus 10. I love how nice and helpful is Teams and OneNote. Sorry, OneNote. It's just so nice that it wants to help me while I'm in a video. Microsoft is just the best. Anyway, okay. So I wanted to show you that. Then I wanted to do this. I want to do one right next to it. Now, obviously, that is not binomial. There's not radicals. There's no radicals there. So let's switch this up a little bit. And let's go ahead and say root x plus 2 times root x minus 5. So you can see these are very similar. Instead of u's, I have root x's, and everything else is the same. So at the end, we should already know what our solution should be here, and that should be u squared. So it should be root x squared. That's what we should have. Minus 3 root x minus 10. That's what we should have, because that's what I did, right? I replaced my u's with root x. So let's see if that works out. So my next step would be right here, root x times root x. There's my root x squared. And before you say anything, yes, I know that's the same thing as x. Root x times negative 5, that's negative 5 root x. 2 times root x, that's plus 2 root x. And then 2 times negative 5 is negative 10. And once again, we have like terms. Negative 5 root x plus 2 root x. Combine those up to negative 3 root x. So that works out perfect. And I just like to do this in this way to illustrate that this is really nothing new, and we're just using properties of roots to do something we've already done before. We're doing the same thing. It's nothing new at all. The only difference is here I got to simplify there. I could have done it right away. Root x times root x. Could have got x. Or I can see it here. U square and a root, they cancel each other out. We get x. Just x. So x minus 3 root x minus 10 would be the answer we're going for in that case. All right. So what is our time here? Okay, we're doing all right. So let's do one or two more examples just for funsies. Okay? Yeah, let's do one more just to really make sure we kind of understand how to do this. So my next example is 3 root x minus root y times 2 root x minus 5 root y. Okay. So once again, I'm going to do what I always do. First term times the first term. So in this case, now we got to be careful. But, we're multiplying, right? So we got 4 factors. Now I can multiply the 3 times the 2, and I get 6. Root x times root x is x. We can do that. So 6x. And then we multiply these right here, and I get 3 times 5. Well, negative 5, that is negative 15. Root x times root y is root xy. All right. And then we got negative y times 2 root x. So that's going to be negative 2 root xy. And then negative y times negative 5 root y. Sorry, negative root y times negative 5 root y is going to be, well, negative 1 times negative 5 is positive 5. So plus 5. Root y times root y is y. And then we still got this issue where we need to combine like terms. Whoops. So undo there. I want the blue. Blue, okay. We got this guy and this guy. These are like terms. Negative 15 of my root xy's plus negative 2 of my root xy's. What does that give me if I combine those guys? Negative 17 root xy. And then, of course, I still have my 6x out front, and I got my 5y in the back. And that would be my answer right there. So I hope this is useful, and you have a wonderful time doing math.